Thank you. Everyone can hear me? We're good? All right. So as mentioned, my name is Larry Garfield. You may know me online as Krell. If you want to make fun of me on Twitter during this talk, that's where you do so. I highly encourage it. I'm the Director of Developer Experience at Platform SH. We're a continuous deployment cloud hosting company. Most of this talk is based on my experience there, although it's not about platform per se. I'm also a member of the PHP Fig core committee. Everyone here is familiar with Fig, right? Yeah, it's kind of like the United Nations of PHP with all the good and bad implications that has, so take your pick. And I am, in fact, PSR8 compatible, for those who get that joke. So let's talk about clouds. Wrong clouds. Sorry, Jeremy McCullough's not here. As I said, I work at Platform SH, which means we are a cloud-based hosting company. And in part of my job, I get to work with a lot of different applications that we're trying to get to run well on our system. And some of them are really good and really well written, and some of them, if you can't see anything nice, don't see anything at all, so I'm not going to mention them. But this is important because we keep hearing in the news and in the market that software is taking over the world, and clouds are where things are moving, and cloud native is the new hot thing for technology, and clouds this and clouds that, and what does that actually mean? What is a cloud if we're not talking about water vapor? Well, there's actually two different questions here, and that's part of the confusion. One is, what is cloud computing? And the other is, what is the cloud? These are not the same thing. These are two completely different answers. The cloud, noun, TM, is the fancy way of saying someone else's hard drive. This is nothing new. It is a marketing term. It has been around since somewhere around 1995, 96, and it is outsourcing. It's outsourcing the physical management of the hardware that your website runs on to somebody else. And that's it. It's nothing more fancy than that, and that's not what I'm talking about today, really. What I am going to talk about, though, come on, is cloud computing. Cloud computing means abstracting away physical hardware from your infrastructure. You think about your computer as logical systems, which may or may not have any relationship with physical box sitting on a rack or in someone's desk or under someone's desk or wherever. This works really well when dealing with the cloud, i.e. outsource that abstraction to someone else, but you don't have to. You can absolutely set up your own cloud computing cluster without outsourcing to anyone else. That's fine. 98% of what I'm going to say here still applies in that situation. The idea here is disposable application design. You've heard the phrase with virtual machines and so on that your systems should be cattle, not pets. So if one of your computers stops working or your system stops working, you don't fix it, you delete it and create a new one. This is applying that same concept to your application of every time I release my application, I'm not adjusting it in place, I'm shooting it and putting up another version of it. Okay. So what makes an application cloud friendly? What makes an application play nicely in this environment of abstracted infrastructure and disposable application? How do we write an application that works well in that type of environment? So what I'm going to be talking about here are not hard and fast rules. These are guidelines and approaches and styles that I've seen that have, as I said, worked well or not well. So you can also think of this as, please don't do these things that make my job harder. First, split your code from your content. This seems obvious, but it's not, because there's some subtlety to it. What exactly do we mean by code? Code is information provided by a developer. It has been carefully tested, right? Right, yeah. And it primarily lives in version control, right? Yes, okay, good. And at runtime, it is read-only. Code should not be modified in runtime. That is a security hole, end of story. There are ways to make it less of a security hole, but it is still a security hole, period. Content, on the other hand, is provided by users. It is frequently provided ad hoc, without any testing, without any vetting process. It could live in a database of some kind, MySQL, MariaDB, Postgres, Mongo, doesn't matter. Or it could be stored on a traditional file system. And it has to be writable at runtime. If it's not writable at runtime, well, then you have a static site. And we're talking about a completely different problem space then. You could be using Amazon S3 or some other remote file system here, or you could just be using a local directory on disk. Doesn't matter. The key thing here is don't mix these two. These should be split by directory. A given directory on disk should contain this or this, but never both. Because quite simply, your application should be disposable, your data is not. If your data is disposable, you are not in fact running in production yet. Which is useful to run things before they get to production, but if you don't have any data that's not disposable, you don't actually have a production website yet. And the flow of information is different for content and for code. So please forgive my terrible art skills here. But you're working locally on your system, whatever it is, and you're pushing and pulling code to Git by whatever process that Lorna was talking about earlier in our first session. And at some point, by some means, on some trigger, manual or automated, whatever, you're going to take what's in Git and you're going to run it through a build process. And that build process is going to take whatever your source code is and turn it into your application. We're in PHP. This is a scripting language. What are you talking about with a build step? Everybody has a build step. If you're in a compiled language, this is your compilation. If you're in PHP, this is composer install. This is Sass build. This is less. This is delete test files. This is whatever other bits and pieces you need to do to turn thing in Git to thing I put on the server. Because basically the days of those being identical ended in around 2012. And you're going to take that artifact and you're going to plug that into your production environment. Whether that's a virtual machine or a container or whatever the underlying technology is, you're going to slot that into your production environment, where you already have data waiting for you. This is user data. Periodically, to make sure your system actually works right, you're going to take that data and sync that back down to development so that you're testing your new code with real data. But notice, code only goes this way and stops, and data goes this way and stops. These are different workflows, and you don't really get an in-between between them. You need to decide if something is going to be code or if it's going to be content, because they follow different workflows and have different rules. Content never goes into Git. Code always does. Our main takeaway here, cleanly separate things that come from a developer, things that come from a user. Never the twain shall meet. Keep them separate at the file system level as well as workflow. Point 2, configuration. Okay, we've got configurable systems. This is a good thing. Is it code or is it data? Well, who's writing it? Is the developer handling configuration or is the user handling configuration? Is your configuration coming through Git, or is configuration something you push in the UI, push buttons in the UI, and update the database? Neither one of these is wrong. Both of these are a completely valid way of building a system. But you need to figure out which one you're doing. For bespoke applications, custom built stuff, this is usually not much of an issue because you don't have end user configuration. You have developers update code or update a YAML file or whatever. But there's relatively little of this. For consumer applications, like any content management system, logging system, shopping cart tools, anything like that, this is a huge challenge. Because you have code, you want to be configurable by the end user, but you also want to have the safety and control and rollback ability of code. And this doesn't really add up nicely. So which is it going to be? Again, I could make a very good argument for either direction in any given use case, but you can't mix them. The most robust answer to this question I've ever seen is the Drupal configuration management system. It started in Drupal 8. In this case, configuration is done in the UI and stored in the database. However, it's built in such a way that it can export the entire configuration of the system to a gigantic directory full of YAML files, which you can then check into Git, push, check out in some other environment, and then import and update the entire database in one big chunk. And that's how you treat configuration as code. And this works 98% of the time, and is horribly over-engineered for the vast majority of use cases. If you actually need something like this, then this is the best, most robust solution available, but is overkill for most of us. So for pretty much anyone else, decide where do you want something to be. Is this user configuration, which can change on the fly, or is this code? Just draw a line down the middle of your configuration and put it on one side or the other. Just decide which one. Additionally, what happens at runtime stays at runtime. What do I mean by that? I said before that you're going to build your application artifact and then plug that into your runtime environment. Your runtime environment has other stuff in it already besides your code, like a database, like the data in the database, like file system information, uploaded user files, that kind of thing, like your Elasticsearch index or your Solr index or whatever search index you're using, and so on and so on and so on and so on. Your application is going to get plugged into this already running constellation of stuff that is managing data and other applications that work with it. And it could get plugged into your production environment, or it could get plugged into some other environment. What other environment is there? Well, staging, I would hope. Everyone has a staging server. Some people also are lucky enough to have a separate production server. I can't claim credit for that line, it just goes around on Twitter, but it's a good one. Maybe you have a multi-head system. So that one application image you're building of your code plus composer install and so forth, you're going to run 16 times on separate webheads that may or may not even be in the same data center. I don't know. Maybe you're doing auto-scaling, so the number of webheads may change over time. Your application needs to be able to handle this. In a really good setup, you don't have a staging server. You have an infinite number of staging servers for every dev branch you're working on. This is how you really should be working these days. So your application really can assume nothing about the environment it's going to run in. Which of these is it going to have at any given time? I don't know. It's going to change out from under it. What you need to do is dependency inject your environment. Your application should approach the environment it's running in the same way a service in your code runs, considers other code. What do we mean by the environment here? Database credentials. These should never, ever be in your code base. One, for security reasons. Two, because they're going to change out from under you regularly. And in PHP, technically, they could change out from under you between requests. You need to allow for that. And by database credentials, I do mean every service. Postgres, Solr, Redis, whatever other service you're talking to. API keys. You really don't want your payment gateway's production keys used in staging environments. You don't want that. Believe me, it ends badly. No, there's not actually a story there. Ideally, you as the developer never even know what the keys are. They're injected into your application in each environment, and it will run with whatever it's given. Any path on disk. One of the very first systems I worked on when I started doing PHP professionally had hard-coded into it the exact path of the application on the hard drive, starting from root. Which meant in order to work on a dev copy of it, I had to move it to a specific directory on my desktop. Sorry, flashbacks. Don't do that. Domain names. You have your production domain name, sure, but that's not running on your laptop. Okay, so I'll just edit my hosts file. No, now you can't touch production. And what about your staging server? Your staging server is going to have a different domain name, I hope. If you have a dozen staging environments for each branch, those are all going to have a different domain name. Your code should not know what its domain name is. It should not know what its root path is. Oops. None of these things should be in your code, and honestly, none of them should be in your database either. You could have relative paths, like you've given my doc root path to an include file or something like that. That's okay. But you as a developer should not know what any of these values are, ever. They will be provided to you by the system at runtime. How? Environment variables are the easy way to do that. PHP, there's a bunch of different ways to get environment variables, and they're all buggy because PHP. Really, getenv is the only one you should use. The $env superglobal is a lot nicer to work with and fails under certain server configurations, including the default configuration of the PHP default built-in web server. Yeah. So don't do that. But how do you know which environment variables they're going to be? You may or may not, because if you run the server, then you can set the configuration of the environment variables yourself however you want. But really, most people aren't running their own servers anymore. They're using some kind of hosting environments, whether it's Platform or any of the other companies out there, all of whom have their own custom format for exposing this information. Sometimes it's an environment variable named this way, sometimes it's that way. Your application, like Laravel wants its database credentials as a series of environment variables. Symfony wants it as a string with all of the information into a URL. We don't provide it in either of those formats. We have a different format we use. That's a nested array. Heroku does something different. Pantheon does something different. All of these hosting companies have a different standard for this. So you're going to need glue code. Just accept this fact. You're going to need glue code to translate from whatever your host's format is for this information into whatever your application expects. And you may not have control over what your application expects if you're using some existing framework or application off the shelf, which most of us are. What does that glue code look like? It's, for the most part, fairly boring code. In Symfony 3, this is what the glue code for Platform looks like. It looks like a lot. It's really quite boring. We store the relationship information, that's the credentials for the database and so forth, in a serialized array, serialized JSON structure. So grab that, decode it, shove that information into the container, because that's where Symfony wants it, because Symfony decided that, okay. We have an environment variable for entropy that you can use for the kernel secret, and that's what it's named in Symfony, okay. This code has been updated recently. We released some client libraries to abstract this away a bit more. I'm still using the old version to show what's going on. The newer libraries are just wrapping this up to make it a bit prettier, that's all. Symfony 3 has a place for us to put this glue code, and Symfony 4 does not. Thanks, Fabien. So instead, all right, Composer package, which has a file that gets loaded before everything else in the autoload process, because Composer lets you autoload a file that just gets loaded immediately. And it does basically this. Which is essentially the same code, but all of the variable names changed in Symfony 4. So Symfony 4 now wants an app secret environment variable set rather than a kernel secret container parameter. Okay, so we map it into that. And it's just a utility function. And we're going to set some defaults on the app environment and do basically the exact same logic as before for the database URL, which Symfony 4 now wants it as a URL string rather than as a bunch of discrete values. Whatever. It's just fairly boring mapping code. And again, newer version of this code is available. This is the version that just shows what's going on. Works pretty well. Laravel is a completely different package that does basically the exact same thing. I'm just using Laravel's setup. So Laravel uses app key instead of app secret. Okay, so we set it to app key. And it wants defaults for session secure cookie, and we can map more relationship information here because Symfony predefines one value for the database URL. Laravel predefines environment variables for the database and for a Redis-based cache and for a Redis-based session. So we can write glue code in advance for all of that because there's more that we can just assume. In any of these cases, if you're doing something additional, you're going to have your own glue code. The more you predefine in an application framework, the more you can automate. Your application is going to need some kind of additional glue code, most likely. If your application has a place, you can just drop in code, some kind of settings or file or config file. Great, use that. If it doesn't, yell at the developer, which could be the guy sitting next to you. Yell at them too. Or worst case, this is what you do in Composer.json, and then this extra bridge file will always get loaded and executed on every request as part of the autoload process, and you can do whatever stuff you want there to set up environment variables, which works only if the application reads environment variables. What about in local development then? .env. .env is a fairly simple library that lets you provide a file called .env that you never ever check into Git. I've seen .env files in Git. Don't do that. You're wrong. Because in production, you're reading those values from the environment, from the Unix system environment. This is what you use locally for development when you're just providing information for your local database running on your laptop. You do not use this in production, ever. You use this in your local environment. And by the way, there's about 5 different .env libraries for PHP. Because PHP, pick one, use it. I don't care which one. They're all fine. They don't do anything really interesting. So use whichever one you like. Also, keep in mind framework-specific stuff. For instance, any system that uses Symfony's HTTP foundation is going to have this set trusted hosts value that lets you say only accept requests that say they're going for my domain. Because if the URL and the hosts mismatch, that's a possible security attack because you can poison caches that way. Except the valid, trusted, legal domain that you're allowed to accept is going to be different on every environment, so set this dynamically. Your application is going to have potentially multiple of these kind of things. Different frameworks are going to do it differently. Consult your documentation, as they say. But this also means never, ever let your database contain your domain name. Yo.
And what hosts?
This is inbound hosts.
Okay.
So the tangent here. If you send a request to example.com, very often it will use example.com, whatever, as part of the URL for any URLs it generates, which then get cached. If you send in a request to example.com with a host header of evil.com, then in some systems that will result in generating a URL that points to evil.com, and that result then gets cached, and so the page cache next time will serve a link to evil.com, and guess what? Someone just hacked your site, or is hacking your customers via your site. You don't want that, I'm assuming. So Symfony, then anything that uses Symfony for HTTP Foundation has this method to say, hey, if the host header is not one of these values, assume it's an attack and bail out. Different frameworks have different options for similar things. Sometimes with some hosts, this may not be necessary. For instance, on platform, we already mangle the host header for you, so that isn't necessary. On other hosts, you will need to do that. Laravel also uses Symfony HTTP Foundation, so it has the same tool here. If you're using Zen Framework, I don't quite know what their equivalent is, but there is one. Look at your application framework and say, all right, what are the things that are going to be different between each environment, and handle those through the environments correctly with some glue code. So how do you make it easy to do that? Is your system configured via constants? Please don't. Constants are globals. Constants, well, are constant. You can't override them, which makes writing glue code more difficult because you can't set a default and then override it, or set something for environment and then call .env or whatever. You have to make sure your glue code only sets it once ever, which makes it harder to do. They make testing harder. If your system uses constants for setting up its connection values, please stop. WordPress. Yes, I've run into this problem. Long story short, dependency inject your environment. It may not be immediately obvious all the places you need to do so, but this will save you a ton of pain and effort trying to move from one environment to another, which you will be doing on a daily basis with any kind of cloud-based system. Related to that, though, what about connections that come from the user? We already talked about things that come from the user are a problem, especially installers. Who here has used a system that has an installer? Everyone here has installed WordPress or Drupal or Joomla or some system like that at some point in their lives, right? Those all have installers. And what does that install process look like? Well, usually the first thing it will do is ask you for database credentials. It will then ask you for some basic site information and write all that to a config file somewhere. Set up your database with default tables and maybe some default content and whatever else. Write the site information to the database or the config file or whatever else, and do some initial population and so on, and you're ready to go. And this fails miserably when you have a cloud environment where you, by design, do not have this information. And writing credentials to a config file, this is a security hole. This does not work in a cloud environment. This does not work anywhere except your local laptop or a handcrafted artisanal server. Laravel can be artisanal, your server should not be. For all the reasons we talked about. Your file system is going to be read-only. Your credentials are dynamic. The workaround for this is, okay, install it on your local laptop, then mutate it, and then push it up somewhere. That's ugly. Don't do that. Who here has written an installer before? A few people. Yeah. A lot fewer people have done that. Those of you who have written installers before, please do this instead. Include the connection glue up front. For, if you know the host that's going to be used with, great. If you know there's a number of hosts that might be available with, installed on, include the connection glue for multiple hosts. That's totally legit. If that code bumps into each other, yell at their hosts because they're doing their client libraries wrong. And make sure you have a place to have a custom glue code in your application in case users need to. Have your installer check, okay, do I already have the database information set up in my environment variables or wherever else it's going to be? If so, don't bother asking the user because you already know it and the user doesn't. Don't download additional code as part of the install process. The install process is a terrible time to run Composer install. You can download data, additional translations. That's legit, that's fine. But your install process should not be downloading additional code. It should not be moving code around on disk because the environment it's running in is hopefully read-only, and so you, can't. You also want to avoid lock-in. What do I mean by that? This is the business part, not the technical part here. You always want to be able to take your business elsewhere. I mentioned before, cloud computing is separate from the cloud, but most of the time you're going to run your cloud computing environment on someone else's cloud that you're outsourcing to, which is fine. It's a completely legitimate way to do business. Most sites do at this point. But you are now dependent on that business, on that third-party business. You want to be able to change your mind. Just like in architecture, you want to be able to change your mind. In contracts, you want to be able to back out if the host you're working with goes out of business or just doesn't like you, or you find that they are stealing your data, or whatever. Even the hosts you like, even the partners you think are on your side, they're not, they're on their side. I'm in business for my company, not your company. I want to help your company, but at the end of the day, we're responsible for our business's stability. You are responsible for your business's stability. That's not my job. How do you do that? By using free software. Don't rely on proprietary tools. Use tools that you can replace. Anyone you are working with, any partner you're working with, can go out of business. They can change their pricing structure in a way that means you can't afford them. They could change their terms of service at any moment in a way that you can't agree to. And you should read those things, please. If your application is dependent on AWS Lambda and it won't run without AWS Lambda, congratulations. You are now 100% on AWS being kind to you for your business to survive. This is a bad place to be. This is just a partial list of what Google has killed off. If you built a business on iGoogle, on Reader, on Buzz, on Google+, which apparently had over a petabyte of data, so someone was using it. You know, if Google X was a major part of your platform, guess what? You're now out of business. Don't build on someone else's land. All of these providers have their best interest in mind. You need to have your best interest in mind, because they don't. So what's safe to use? Your standard open source set of tools. All these things that you could install yourself if you wanted to. You may not want to, you probably don't want to, but you can, which means you can also pay anyone else you want to install it for you. If you're using Postgres and RabbitMQ for your application, and you're hosting with this hosting company, and that hosting company goes out of business, great. You have a recent backup. You want a recent backup. And there are about 4,000 other companies you can go to and say, hey, I've got a Postgres database and a RabbitMQ configuration. Please put this on your server. And they can do that, and you're back in business. If you're using a proprietary system from any of these, or any other proprietary system or service, then they go out of business, or they change their API in some way, or their pricing changes, guess what? You're SOL. If you're dependent on a third-party platform, then you are dependent on a third-party platform. You don't want that. I'm not saying no, don't use third-party services. I'm saying don't use proprietary services that you can't replace. Everything these days is interconnected. Make sure you can change your interconnections. This is not a problem of cloud computing. This is a problem of the cloud. And finally, we can't talk about clouds without talking about everyone's favorite cloud topic, microservices. Who's built stuff with microservices? Decent number of people, okay. According to the marketing, clouds enable microservices are, right? Okay, what's that? Thanks. What is a microservice? I don't know. Based on the literature, kind of the rough consensus I found for what a microservice design means is this. Microservices are single-purpose components running as their own processes, as their own applications. They communicate with each other through dumb, generic pipes. HTTP, interprocess communication, WebSocket, some non-proprietary API. They are built by separate teams. You have a different team building your user API service from building your web API service, from building your customer data service. They have independent release schedules. You can ship a new version of this microservice on Tuesday, and that microservice on Friday, and that microservice next week. And they don't have to coordinate. This is at least going by Wikipedia and Martin Fowler kind of aggregating their descriptions. Essentially, every microservice may as well be a third-party company. That's microservice architecture, where it's not just multiple processes. It is, in fact, separate business entities managing each piece and then talking to each other as customers. Now, Who's built a microservice? Somewhat smaller number of people. This does have a lot of benefits. You can use different tools and different languages for different components. You can use Go for this piece and Node for that piece and PHP for that piece. You can have a small team focused just on the one user pool service. And you've got an architect there, you've got developers there, you've got usability people there, you've got API designers there. Different team with full suite of skill sets working on some other piece. You get very strong separation of concerns this way because you have different teams that aren't always talking to each other by design. And so you get a very clear boundary between those components. Which also means you can scale very easily. You need to throw more hardware at just this one service? Okay, you do that. You need to scale up this one service? You can do that. You want to rewrite this one service completely in a new language so that it's faster? You can do that. Most of these benefits come not from the technology, but from the fact that they are separate teams. They come from the fact that you're dealing with different corporate entities rather than a single team. That's where microservices come in. This is Conway's law in action. Any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. How many times have you had to tell your clients that their org chart is not how to design a website? I lost count at 17. I used to work with a lot of universities. Microservices are leveraging Conway's law to help keep your architecture separate. So you have a team working on this piece and a team working on this piece, and they don't talk to each other, and that's a good thing, which means those pieces stay separate, assuming you want them to stay separate. There are drawbacks, though. Network latency. The network is, about 1,000 times slower than communication between functions in your system. Maybe 1,000,000 times slower than functions in your system. Anytime you add the network to it, you add at least 50 new points of failure, which will fail about 1,000,000 times more often than a function calling a function. You have to be prepared for any given request could just disappear into the ether at any given time. Moving code from one system to another gets substantially harder. They may not even be in the same language. If it makes sense to move this routine from this microservice to that microservice, that's a major lift. If it's all one system, then it's reconfigure your dependency injection container. You have to deal with API versioning because you can't coordinate releases of different components, so you have to deal with API versioning between them. Who's dealt with web service API versioning before? It sucks, doesn't it? How'd you like to build that in at a core part of your system? Yeah. And you need more people. You need to have a complete team running each of these microservices. Having one team running multiple microservices means you don't have microservices. You have one team managing multiple Git repositories. That's not the same thing. And when dealing with PHP, let's remember every PHP request has a boot up time. It has a startup time where every request that has to start, it has to autoload, it has to initialize the container, it has to open database connections. PHP, quite frankly, is not well suited to high-frequency microservices because of that problem. There are things being done in PHP 7.4 that will help, but if you have a microservice that has to be very, very fast response time, PHP is not the right choice. I'd probably go with Go or Rust. I don't know who said this originally, but I've seen it a bajillion times, so I'm just going to credit the internet. If one of your microservices going down means that the others don't work, you don't have a microservice, you have a distributed monolith. Because the one HTTP request internal within your network getting lost kills your site. You don't have microservices, you have a big hairy mess that is subject to the whims of the network, where gremlins live. So what else? If microservices are only useful if you are Twitter, Google, Amazon, or Facebook, does anyone here work for Twitter, Amazon, Google, or Facebook? Okay, you probably don't need microservices then. My recommendation instead is clustered applications. This is a term I made up. There is no standard term of industry, so I'm inventing one because I get to do that. What do I mean by a clustered application? Single team building it. It does have discrete components. Cool, okay. But it all deploys as one big system. It still deploys monolith style. Most of the time, this is going to be written in a single language, in a single repository. Not always, but most of the time, you're just going to use one language for it, whatever that language is. It's OK for them to share data stores. In a microservices architecture, the database for the user service and the database for the customer service, they don't know about each other at all. You're not allowed to talk to each other. In this case, that's totally legit. They're all just talking to the same database. That's fine. You have probably built one of these before, several times. Who's used cron jobs before? Clustered application. Who's had a separate web front end for an admin area? Clustered application. Who has done something with queue workers? Clustered application. Who's had a separate app to handle the API on top of their system that's separate from the web front end? Clustered application. These can all be in one code base, or they could be separate code bases. I find one code base is a bit easier. You could write them all in the same language or multiple languages. It used to be really common to have a PHP application and then a queue worker written in Node. These days, PHP works just fine for queue workers, but there's no reason you can't still use Node for that. You could, if you're deploying with containers, you could put these all in a separate container, or you could all have them running in a single container. Doesn't matter. If they're in separate containers, you can potentially scale them independently. But ideally, that is a question that you can decide without modifying your code. Worst case scenario, you just deploy multiple copies of your application to different containers and use a different startup script in each one. Works great. What do all of these have in common, though? How do we know that we're doing a clustered application well? What's the common elements of these? Any guesses? What's that?
Shared database.
Shared database, but in terms of the kind of use case, what's common to all of these?
Yeah.
They're all asynchronous. All of these are things where a given web request is only going to touch one PHP process. That PHP process may kick off stuff in the database for a cron job to pick up. It may toss something into a queue. But you only do the work you need to respond in one process, which means if the queue is down, you restart it later. If cron skips one run, you run it again later. PHP works really, really well in this model because it works really, really well for a single process handles a request. You can scale out horizontally amazingly well. And anything you kick off to later is later. Who cares? PHP works really, really well here. And this is still far less complex than a monolith application. In part because it is a monolith application. You just have a cron PHP file sitting next to your index PHP, and you have an admin PHP sitting next to your index PHP, and so forth. This will scale just fine for 95% of use cases. And for that other 5%, you're Google or Netflix or Amazon or whoever. To summarize then, the last 45 minutes, don't assume things. That's how you make code cloud friendly. You don't assume things. You don't assume the environment it's going to run in. You don't assume the number of webheads you're going to have. You don't assume what your database connections are going to be. You don't assume what domain name you're running on. Don't assume that you have a writable disk. Don't assume that you are big enough that microservices make sense. You're probably not. And that will give you a code that will run on pretty much any web host, any cloud-based host with minimal glue code. And that makes your life and my life a lot easier. So thank you. And I think we've got about 5 minutes for questions, if anyone has. Yes?
You said there is something coming in PHP 7.4 that could help with microservices?
Yeah, so PHP 7.4, for those who haven't heard yet, it's due out November, December this year, has opcache preloading in it. The short version is you'll be able to configure a script in index PHP, in your PHP ini, that when the server starts, when PHP FPM starts up, it runs that script, which can grab a bunch of files on disk and say, hey, pre-compile these. And then not only does it load the file and op cache it, just like we already have, it keeps that op cache in memory. So when you get to your actual script, the class is already parsed and loaded. The current op cache just handles caching of the opcodes, but it doesn't actually load it into memory. When you start the script, it will already be in memory. You don't even trigger an autoload to get to that file at that point. I've seen, depending on your application, that can save you like 20% on your CPU usage at the cost of some memory usage. There's still some debate about what the optimal trade-off point is. That's going to vary by application. But from what I've seen so far, the benchmarks I've seen, just load everything will burn you some memory, but the CPU trade-off is totally worth it. So if you are in a container or a VM where your application is the only thing running, preload everything is probably going to be the default, and that'll be a big performance win, especially if you have an application that's a lot of classes. So that'll save a lot of the startup time that PHP has. Not all of it. There's still a lot of runtime startup, but that will help a great deal with just making the boot up process faster.
Related, is it comparable with Symfony Cache One?
Just with Symfony's cache?
The Cache One?
It's like, you know, APC, shared memory. So FPM boots, that's the thing, it's not about. Set some shared memory, and then every time you get requests in, they're different threads, but they all have the same shared memory. So do it once. And then every request doesn't have to do composer autoload for everything, because you do your composer autoload sort of once for things that you're going to need for ideal for every request.
Yeah.
Not over being over, right?
The way to think about it really is assume that all of your classes have already been autoloaded by the time your index PHP starts. And that's actually a pretty good chunk of CPU time just loading and linking all of those things. So that's going to be a really big feature in 7.4. Yeah. Other questions?
With things like installers, is there a middle ground pattern where you would recommend for just like a few config settings, it's worth having some storage so that people can set up on cloud, or does it just never make sense in that context?
Tricky question. It's going to depend on what the details are. I'm going to say it comes back to, is it environment sensitive or not? If it's environment sensitive, then it should be an environment variable or possibly a file on disk. If it's something that's not environment sensitive, it belongs in Git. And you can't put things in Git from the installer, so find some other way. Is this a value that should be environment sensitive or not? You're going to have to answer that for your own application. But that's really the guideline I would give. Yeah. There's another hand over here. Yeah.
Suppose probably a lot of us here have got applications that do all the things that you've just told us not to do. Suppose we start trying to solve them. How will we know when we're done?
Well, OK. So the question for the recording, if we've got an application that's doing everything wrong, how do we know when we've got it modified it to do it right? The self-serving answer is try running it on platform, and when it works well, then you're done. Barring that, I'd say first thing you do is make sure that every given directory is either code or data. And for some of that, do you have a place where you can build an artifact and run it? If so, make sure that's read-only. And if it's read-only and your code breaks because it's trying to write somewhere that it can't, OK, you've still got a bug. If you have generated code of some kind, that could go either way. If you can generate it without using a database, then you can probably just produce that as part of the build process. If that is dependent on the database or user configuration, that's technically then data. So treat it like data. Make sure you have your code running in multiple environments on a regular basis. Local laptop, production, testing, other testing, other testing. If your code can run in all of those without modification, then you're dependency injecting correctly. And make sure all of those have a unique domain name or other identifier. I think those are the big ones I usually run into. And then make sure that your installer does not write anything to disk that really ought to be in Git, including database credentials. Database credentials should always be handled via glue code. And again, that mechanism is going to vary host to host, so make sure you have a place to do that glue code for whatever host you're working with, including self-hosting. So is that a reasonable set of guidelines?
Yes.
Okay.
A wee tip. In your index file, chmod your code directory, remove writable permissions, see what happens.
Yeah, that's a good way as well. Just
Very simple, but you'll know if your app is relying on a hard drive, which is a cloud hard drive, which won't go away. So if you're trying to transition to cloud, then do it right.
yeah, I mean, if you don't have a read-only environment, you can create one just by playing with your file permissions. So that's totally and kind of a cheap trick to do it, but it totally works. Others? Thank you for coming. Enjoy lunch.